Hey folks, so in this video we're going to continue with our kind of stack improvement project. So we've already made a lot of changes to the original stack. We started with an array-based one. We did some pretty good work, but then we were kind of left with this idea that, hey, maybe there's a way to do things a little bit faster, right? We had this observation that there's a resize required, and we thought maybe we can make things better. And then we actually started looking at basically a technique to do that. We started talking about the idea of a linked list. And so in this set of videos, what we're going to be doing is basically applying that idea of a list, right, of a linked list data structure to implementing a stack, right, with the hope and dream that it'll maybe give us some more, faster solution than what we would otherwise have. So let's think. Okay, so we have, first of all, right, we've basically seen, right, or reviewed another type of data structure, right? So the most basic data structure we could possibly use, right, is an array, which is exactly what we started with, right? Our first implementation of a stack, we did it with an array. Now we have another choice, right? Now we have a choice of maybe a list, right? So the question here, right, is, will a list be useful to me, right? Will it help me to achieve faster performance or lower memory usage or something like that, right? And this is a very typical question to ask, right? So whenever you go and you implement an ADT, right? So here it's a stack. It could be something like a queue. It could be, all these other different things. A big question we always find ourselves asking, a big question we always find ask ourselves is simply, what should I use to store my data? And I have my choices, right? Array or a list. So this is, a very general thing, right? So maybe even the first thing you start with when you go to actually implement something, right? You may write a specification, you need to implement, what do you do? How do I store data, right? It's an early question. And so the way we usually answer that question is by trying to understand how that ADT manipulates information. What sort of operations does it need to support? How does the data need to flow behind the scenes in order for those operations to work, right? By thinking of those things, we can try to pick what is the most appropriate data structure, right? What is the data structure that supports them the fastest? What is the data structure that maybe lines up with those ideas in the best possible way, right? That's what we want to think about. So for us, right, we can think about first the idea of a stack, right? So what does a stack do? A stack, first of all, has to support basically adding and removing elements. When it comes to adding and remove elements, that's a very typical use case for something like a list. One of the big limitations of like an array is simply that it has a fixed size, right? So when I create an array, it has, for example, 50 slots in it. It's going to be 50 slots, right? It's hard for me to go to that array and say, oh, I need a 51st slot, right? Generally, what I have to do is instead create an entirely new array of this larger size and copy the contents of the original to the brand new array. This is typically a bit of a performance concern, right? We end up having to spend basically O of n time to move every little element over. So if I want to add or remove elements, usually it's going to be more appropriate for me to use something like a list because I can just update those little links, right? I don't need to change everything that's in there. I can just move the links around to look like the new way that I want them to look like. Okay, so this is kind of an overall view. And that's something, right, that basically is applying to stack, because in stack we want to be able to add elements, we want to be able to remove elements, right? That's the key thing there. So for us, it actually would make sense that we use a list to implement a stack. And so what we kind of want to do here, right, is maybe get something that's faster than we already had. We already talked about basically the idea of pop and push, right? And for like something like pop, we had O of 1 that's already pretty fast. Then the other one that was a little bit slower was the push operation, right? Because there's a chance it's already full, and when we go to add something, we need to make more space. How do we deal with that? Well, a list will deal with that much better, right? Because I can just attach something to a list, right? And so actually, if I go to basically add an element to a list, I can do that in O of 1 time. Well, at least I can add to, for example, the front or back of a list in O of 1 time, right? And that actually will work out for us just fine. Now, there's a couple of important notes here for us. First of all, right, if I want to manipulate a list, right, it is hard to do things in the middle, right? That's fine. That's just the way the world works, right? But for us, it doesn't really impact us because one part of the stack is, oh, I only make changes at one side, so it's not a big deal that it's hard for me to reach into the middle of a list and select a specific element, right? That doesn't really matter. I'm just constantly working at one edge, which kind of lines up with the basic concept of a list, right? So a list would be a good choice here, right? And I think, right, and hopefully maybe you can think about it yourself for a second, the performance will improve. It'll improve by a factor basically of it'll go from being linear time to do a push in the worst case to being constant time, right? We'll be able to just add that one element. We won't have to worry about shifting stuff around. All right, so this looks like a good direction for us. In the next video, we'll start by implementing a kind of a node class we can use, and then we'll walk through basically recreating better stack, right, to use a list to store data instead of an array. And at the end of the day, we'll end up with this brand new stack that has basically constant times for all the operations that it supports.